Hello everyone, welcome back. If you are an R user who thinks that Tidyverse is the ultimate data analysis toolkit, there is some exciting news. R's Tidyverse principles are so useful that they are already being adopted by another language, Julia. Julia, known for its speed and efficiency, has embraced the Tidyverse philosophy with its Tidyer.jl package. In a short span, Tidyer.jl has skyrocketed in popularity, collecting hundreds of stars on GitHub. Tidyer.jl is similar to the Tidyverse package in R, so it can be thought of as a meta package that imports a set of smaller packages, all adhering to the tidy data philosophy. If you want to learn more about Tidyer.jl and its creator, Karandeep Singh, if I'm pronouncing it correctly, and his motivation in starting to develop it and its current state of development, you can follow Singh in Twitter and GitHub and watch his recent very interesting talk in JuliaCon 2023. So let's dive into action. Today we'll handle a real-world data analysis scenario. We're going to clean a horror movies dataset and prepare it for calculating movie similarities using cosine distance based on OpenAI embeddings of the movie's overviews column. You will see how to fetch them in a minute. And for doing that, I'm going to be mirroring the R code that Julia Silge has presented in one of her recently uploaded videos. For those unfamiliar, Julia Silge is a shining star in the R community, known for her expertise and generosity in sharing knowledge. Do check out her blog and YouTube channel. I will include the relevant links in the description below. Coming back to our approach for calculating movie similarities, we will first be using Tidyer.jl and then vanilla dataframes.jl. Alright, so what I'm going to be doing is take the R code that she uploaded in her blog post and translate it into Julia with and without Tidyer.jl. I opened here the same file in two separate views. Basically what you see now is the contents of the file in two different spots. First, let's gear up by loading all necessary packages. We'll then fetch our horror movie dataset and initiate the cleaning process, following Julia Silge's steps with Tidyer.jl. Let's download the dataset with the download function and set a common seed for the two versions of Julia code, with and without Tidyer, so that we can compare the results and confirm that both versions have the same result. So the first thing it does is it filters out the rows of the overview column that are missing and keeps all the rows where the original language is English. Let's try to do that using Tidyer.jl this time. The filter macro accepts columns names as its arguments without the column prefix, and the only thing that changes and needs to be learned are the isMissing and isEmpty functions that return Boolean vectors for filtering out the empty or missing rows in the overview column. Let's go to the vanilla dataframes.jl solution. As you can see, there are notable differences between the Tidyer's filter macro and dataframes.jl filter function. First of all, the filter function takes two arguments, where the second argument is the dataframe object. Here we need to use the underscore to make the code compatible with the chain macro and the pipe logic of processing. The first argument of filter may either be a simple condition if we have only one condition, or a complex condition if we have more than one condition. In our case, we have a complex condition since we filter the data frame rows based on three conditions: the rows that are not empty or missing, and those rows where the original language is English. The complex condition is expressed through the double ampersand symbol for logical conjunction instead of the comma used in the Tidyer.jl version of the code. Moreover, you also need to refer to the column names through the colon prefix that indicates that we deal with a symbol. To pick a random sample of 1000 rows of the data, we very simply choose the slice_sample macro that is recently integrated in Tidyer.jl. one of those smaller packages included in the Tidyerverse meta package. On the other hand, the vanilla dataframes.jl solution, although clear and concise, is slightly more verbose. You first choose the unique function to avoid duplicate rows and then use row indexing along with the sample function. Since we set the same seed in both with and without Tidyerverse.jl, the resulting data frame with the sampled 1000 rows is the same as you can see. The glimpse function in Julia Silge's code is directly translated with the glimpse macro that gives a quick overview of the data contained in a data frame. As you can see, among others, the output includes info on the number of observations, rows, the number of variables, the columns, a list of the variable names, the type of data each variable holds, and the first few entries in each variable. Next step is to create the embeddings for the movie description in the overview column. At this point, we will be using the create_embeddings function by the OpenAI.jl package that will do the heavy lifting of calling the OpenAI server through the OpenAI API with an API key that I already created in the OpenAI webpage. There are various sources out there that guide you through the process of creating a new API key, and I will skip that part. Now, the resulting response object, called resp in here, is a JSON3 object that among other properties includes the response property that essentially corresponds to a dictionary with 4 key value pairs, the most important of which is data. That is where all the embeddings reside. The only thing that remains to be done to get these embeddings is to loop through the data array. Each member of this array is an embedding, which in its turn is an array of 1536 float values for each row in the overview column that has the movie description. Essentially, with this array comprehension, we will end up having an array called embeddings that includes 1000 arrays of 1536 float values. Next step is to store this array of arrays as a new column in the horror movies Tidyr data frame first and in the horror movies without Tidyr afterwards. We can use the Tidyr data's mutate macro and the double exclamation mark before the variable name embeddings to indicate that this is not an existing column name in the horror movies Tidyr data frame. Or in the case of the horror movies without Tidyr data frame, I can simply use the dot operator to create a new embeddings column. Let's have a look at horror movies Tidyr and horror movies without Tidyr to make sure that both data frames are identical. Then, Julia Silge focuses on 3 columns: ID, original title, and embeddings using the select function. Here, again with Tidyr's select macro, we do not need an array of column names prefixed with a colon. You simply put them side by side, separated by commas. Now we'll spread our embeddings across new columns. While tidyverse.jl's unnest wider function is still in the works, dataframes.jl offers a handy combination of by-row and vcat functions to achieve this for both horror movies Tidyr and horror movies without Tidyr. The resulting data frames include new columns, and each of these new columns map to a separate value of the 1536 embedding values for each row. Recall that each row corresponds to a separate horror movie. Notice that we left out the initial embeddings column with the not helper function. Now let's pick a random column name, the 30th column name for example, and see the column name of one of these new columns. As you can see, the naming pattern for the new columns is X followed by a number, starting from 1 to 1536. Now, following Julia Silge, it's about time to find out similarities between the horror movies based on the overview embeddings. To do that in Julia, I used a very useful and fast package called distances.jl that includes a big number of distance metrics. We will first need to isolate only the columns that carry the embeddings information, namely the columns with the 1536 floats for each movie description. As you can see, both the select macro and the select function can take a regular expression. Now, each row of horror movies Tidyr embeddings and horror movies without Tidyr embeddings has 1536 columns, and we need to be able to compute their similarity to the other rows of the same size. Julia is a column major language, which means that the most effective way of comparing pairs of 1536 float values would be to first transpose the matrix and then compare its columns. However, the size is not prohibitively large and we could stick to comparing rows. So after converting the data frame into a matrix and doing a pairwise comparison using the cosine distance in the first dimension, namely between rows, we can take R, which is a similarity matrix between the horror movies. Rows and columns in R correspond to movies, and its cells are the cosine distance values between the movies in the corresponding row and column. So the cell in the fourth row and third column, for example, is the cosine distance between the movie in the fourth row and the movie in the third column. Let's follow Julia Silge's code and take the fourth movie, Belbo the Clown, using the slice macro, and with the select macro focus on the title and overview columns. As you can see, to do the same for horror movies without Tidyr full data frame, you would need to be a bit more verbose and not so straightforward. Choosing the fourth row returns a data frame row and not a data frame. That is why you would need the data frame constructor before selecting the title and overview columns. The last step is to sort the horror movies based on their similarity with the fourth movie, Belbo the Clown. Let's use the sorted indices for getting the titles of the movies, starting with the ones that are closer to Belbo the Clown and moving on to the more distant ones. Lastly, let's use the select macro and the select function to get not only the titles, but also the overviews of these movies. I hope you enjoyed this exploration into extracting embeddings and computing cosine distances, both with Tidyerverse.jl and vanilla dataframes.jl. Stay tuned for more data analysis scenarios using the Tidyerverse.jl ecosystem, as well as the vanilla dataframes.jl package.